So good afternoon. This is lecture 19 of Python for Machine Learning course. In today's lecture, we will look at a data analysis library named Pandas. So it is one of the most popular data analysis library around. So every machine learning problem, ultimately you will be using this particular library at some point. It's also a very simple thing, just like our NumPy or Matplotlib. You can import that to your Python program and do the analysis. So before going into the details of NumPy, the Pandas. So let us look at some simple programs and then explore how a real world data looks like. So today's lecture, what I will do is this. So I'll be a bit slow today. So I will introduce you to Pandas. Then I will introduce you to one data set, a real data set that people use for statistical analysis or machine learning tasks. Then using that data set, we will come back and explore Pandas again. So that is a plan for today. So let us straight away go to our slides for this lecture. So let me present it. Here it is. So this is what Pandas is. Pandas is a scientific library built on Python. So Pandas can handle many kinds of data. So far, we have seen NumPy arrays, lists, dictionaries, tuples, many data handling mechanisms. But from among that, see, your Pandas is most suitable for handling tabular data. Some of you might have seen Excel sheets. Some of you might have seen CSV files. That kind of, say, in Excel or that spreadsheet, you have a tabular kind of data. You have, in one side, you have, say, some numbers or row numbers, and some you have column headers. So we'll look at tabular data and see how such data can be captured inside Pandas. Secondly, Pandas can be very forgiving. See, for example, when you collect data from field, maybe from a survey, some of the data fields may go missing. People may not give you enough data. Some people will refuse something. So maybe you will have to deal with such missing data or data that is out of range. So such things can be very easily taken care of by Pandas. So let us look at the data structures that Pandas provide. So Pandas, in fact, actually provides two kinds of data structures. One is called a series, and second one is called a data frame. So we will look at data frame first, and then we will go to series. So typically, a Pandas data frame or a tabular data will look like this. See, for example, say take your class. In your class, you have different students. So each student has some attributes. Say he has a name, he has a gender, he has some marks, some address, like things like that. So if you look at this, if you collect such a data from your class, see the top row marked in black. You see the top row marked in black. So that corresponds to various attributes. Maybe the first thing can be your name here. So I'm placing the cursor there. So this can be your name. This can be gender, this can be your age, or many things are. And here on the left column, or the first column marked in black or gray, that will be containing names of various students. So your tabular column will, this kind of tabular column will have some column information and a raw information. So the column information typically will be corresponding to different students or different samples from which you have collected data. And the column, each column of this tabular data will be one attribute, one attribute. So let us have a look at data taken from say a spreadsheet. You look here. So here I have taken some image from that LibreOffice Excel sheet. So the first column here named A. This column named A. See, this is marked 0, 1, 2, 3, etc. See, these are record numbers. So the first record, that is this particular Mr. Owen Harris is 22. He's a male. Similarly, the second one is second row is another record. Third row is another record. So this is a kind of data or data frame data that we will be handling. So I hope you understood the idea. Now, each column in a data frame is called a series. So this particular thing will be a series. So one column will be a series here. So we'll see details of both. Okay. So this is the basic data structure that we will be working on. So this particular data structures, data frame and series is very important and extensively used in data analysis and machine learning. So let's build a small data frame and then see how things look like. So let us go straight away to the next line. So as I told you, the Pandas is a library built on Python. So you can import Pandas module as Pandas as PD. So PD is some name. People as convention, or people will import Pandas as PD, but that is not necessary. You can use XD, XY. Is there any valid name you can give? But in general, people tend to write Pandas as PD. So we will also stick to that. And now we are going to create a data frame. So data frame needs some kind of data. So the data I have collected as a say dictionary here, as a dictionary data structure here. So here, look at this. So name, so various names. So this is one column in our proposed data structure, that is a name. So you have Anup, Nisha, and so on, so on, so on. And second column is age. So they have some ages written. So this is a typical dictionary data structure. So within curly brackets, so here it starts and ends with a curly bracket. So here is the name, key. Here are the values. This is the value of the dictionary, key value. As a key value pair, we are creating this particular dictionary. Now let us run the code here. Let me run the code here. Run. So run. So okay. Now my data for the creating this particular data frame is this. So this is what has been created. Now I am going to call the data frame method from Pandas library. PD. This is what you have imported from Pandas as PD dot data frame. You look at the spelling. D is capital, F is capital, and then you are giving this particular data. So this will create a tabular data structure as shown below. Let's say, let us run it and let us print to the tabular data structure. So if you look here, I have created a tabular data structure as shown here. This is a typical data frame. Now DF is a data frame with the 2 columns, and there are 4 records. Each record contains a name and an age. So let us expand this with some more things. So let us expand our data frame with some more things. So I have expanded. So I have rewritten the data here. Say the dictionary. So there are 4 columns. So name is one column, age is, address is another column. So qualification is another column. So in each column I have given a list as the prospective values. So let us run this, and I am creating a newer data frame with this particular data. And if I print it, so I have a better data frame. So using this data frame, so this is the idea behind data frame. So you have tabular data structure defined. So one column of this, say maybe this particular column, name column. So this is a series. So this contains 1, 2, 3, 4 series stacked together. Okay. Now the good thing with Pandas data structure is that you can access each column. For example, if you want to access the name alone, okay, name and qualification. So that is what I have written here. Name and qualification alone. You see here the title here. You just take the title, give it that here. So you see how that is done. Maybe I will expand it slightly. So this belongs to the print statement. So now within df, see from the data frame, I am choosing these particular 2 values. Say within this is actually list. This is actually a list of values. So name is this column title, and qualification. So when I run it, I get these 2 particular things. So if you see, actually you can maybe you can edit it to have only the name. So let us see. Only the name. So you can even have maybe is it? Yeah, what I did. Qualification, then comma, maybe address. So you can reprint it in any reasonable manner. So you can access these things. We will come to access methods later. So this way you can access things. So of course you can access row wise. We are coming to that. So this is the idea behind a Pandas data frame. Now, so there is no point in continuing with the artificial data frames like this. So I will introduce you to a real world data which people use for real calculations. So for understanding that real world data, you should know a little bit of history. Say maybe let us look at something like this. I hope some of you have seen. This is a flower. This is a particular kind of flower seen in some part of Canada or in that Northern America. This particular kind of flowers are seen. Somebody came up, no? So this particular flower is called an iris flower. This is called an iris flower. This particular flower, maybe you will find some similarity with some of the flowers you see in our place also. So if you carefully observe this particular flower, you will see 2 layers in the flower. So there is an outer layer and an inner layer of that individual leaves, flower leaves, or some, I don't know what exact name it is being called. 2 layers. Now, in the case of iris, you call the outer layer as sepal. It is marked there. And inner layer of that leaves as petal. So there are 2 layers for this particular flower, sepal and petal. So in this particular Canadian Valley, I forgot the name of the value. You can just look up iris data set. So a professor, a biologist named Ronald Fisher conducted a study in 1936. It's very long back, maybe say nearly 100 years back or 90 years back. This particular biologist conducted a study of this particular type of iris flavis. Then he found out that there are three kinds of irises, not just one. Not just one. Okay, there are, where is that? Okay, I will show you different categories of. There are three different categories of iris flavis. You can see it on my screen. See, they are from the same family, but slightly different. The thing is that some of them have different shaped petal or sepal. So you see the three kinds of iris flavis. So one is called versicolor. The first one is called versicolor, setosa, and virginica. These are the three different categories of iris flavis found, that Fisher found. So he made a study of this flavis. What he did was, he collected 50 samples of each of these three different categories. He on the same day, he collected 50, 50, 50, or versicolor, setosa, and virginica. 50 each was collected, and he measured 4 parameters from these 50 samples. So there are total 150 samples, 50 each for each. He measured he took a sepal and he measured the sepal length and sepal width. You see the two lines that I have shown on the figure. These two lines represent sepal length and sepal width. Similarly, he measured petal length and petal width. And so he had, so altogether for each flower sample, he had 4 values. 4 values. Sepal length, sepal width, petal length, petal width. For each sample of the flower, he had 4 parameters or 4 features measured from your samples. And he published this data. He published, Ronald Fisher published this particular data in a biology, some magazine, some publication, he published it. And ever since that time, this particular data is extensively used for studying statistics, machine learning, and data analysis. Sepal length, petal length, and petal width. So he collected these values. So these values are is available in public domain as a single data, as a data. So this particular data is presently available for you as a CSV file. And so let me explain what exactly is a CSV file. So as I told you, each sample has 4 parameters. And see, each parameter is represented as a single row with its category. Now, see, this is available as a CSV file. CSV means comma separated values. So I will tell you what exactly it is. So let me. So here I have kept those 150 values in a CSV file. So CSV means comma separated values. So let us examine what this file contains. Cat. So I am dumping this to my screen. So this is the content of the file. So in the CSV, this is the content of the CSV. The first row of this file represents, first row of this file represents what? The titles or value, what exactly this file contains. You see this, the sepal length, sepal width, petal width, and variety. There are 4 plus 5 values in this particular CSV file. And see, these titles are separated by commas. So each value is also separated by commas. That is why this is called a CSV file. So 5.1. So this is the first value. 3.5 is second value, and 1.4 is the third value. 2 is the fourth value. And its category, say when he took measurements from the first Setosa sample, he got these values. See 5.1, 3.5, 1.4, 2. So the category is Setosa. That is what is written here. So typically a CSV file will indicate values in numbers or category values in plain text separated by commas. This is what you get in a CSV file. All the 150 values are written here. See, the first 50 are Setosa, second 50 are Virginica, and the third 50 are versicolor. So this is how this particular file is organized. So in general, when you go for data collection, when you collect data, you will also you will collect data in this manner. So if you are doing your own experiment, your data collection on something for data analysis purpose, you will also collect values in this manner. So all the values will be there, a category will be there, and all these values will be separated by commas. So this is the idea behind a comma separated file. So your data will be available in CSV files. Now your task is to read this into a data frame, a Python, Pandas data frame. So Pandas library can read Iris this data, CSV data sets into its workspace and create a data frame. So let us see how we have done that. So let us again go to that slides for today. So let me present this particular tab. Yeah, where is this? This one. Okay. So this is that CSV file can be opened in your LibreOffice or Excel or also or any spreadsheet things. So they will also represent or display it to you in this manner. Okay. Now the iris.csv, I have just shown you iris.csv in this particular folder. You will find, you have to place iris.csv in the folder in which your program is operating, or else you have to specify the exact path to the iris.csv. So what I am doing is, from using the Pandas read CSV, Pandas provides a particular special method for reading CSV files. Similar methods are there for reading Excel files also. You can find it out. You can actually import an Excel file also if you have an Excel spreadsheet or something. So read CSV, your CSV file. So this particular command will create a Pandas data frame from this particular CSV file, and as this particular data frame will be named with this way, iris. This way I have named. So let me create it. Run. So I have created. I have read it. So let me look at the iris data set. So the iris data set, inside the Pandas, as a Pandas data frame, it looks like this. See, there are 150 into 5 columns. So it has been read into your workspace. Now let us look at say the sepal length alone. See, run. I am reading. So the column titles are taken from the first, these column titles were taken from the first line from the CSV. The first line of the CSV, first row of the CSV was the column titles. Okay, so if you want to print the sepal length alone, you can do it like this. Say first line, iris, say within that square bracket. You should give the exact name. If you change a slight difference in change, so this will make an error. So you can print the first one, this one alone. See, can we print it like this? So similarly, maybe you can print the category alone. That the fifth column alone can be printed. Where is this one? This one. Where were you? Okay, here. Right. So category. For some different samples of the categories are there. Now, once you have this data frame, you can do all kind of manipulations. Manipulations like plotting, printing. See, all kind of data analysis can be done. So I will give some preview into some of the common functions that we use in connection with the data frame. Maybe in the next lecture we will do some kind of analysis on this. So maybe if you can look at the head, this means the first 5 lines will be printed. If you iris.head will print the first 5 numbers. If you give a numerical value here, say first 10. If you want to print the first 10, you can print it like this. So maybe the first one. Let's see what happens. See, only the one particular column was printed. So it is also possible. Actually, you can 2:3. This way also I think you can print. Yeah, you need to specify that in something like this. Yeah, okay. Let me see how to choose this thing. Wait a second. Okay, we'll come to that selection later. So you can actually from this you can sample these things. So most of the times you need to take random samples from your data. So this is another idea. So I'm taking some 20 random values from this random columns. So if I run this, it will give you some 22 random values from this. So again, let's see. Run it once again. It has chosen another sample. This is very important. Maybe in statistical terms, you can choose random values, randomly select things, and choose values so that you can do random experiments. Yeah, this was what I was telling. I had made a mistake here in the earlier. Yeah, for choosing these values. Okay. Yeah, you can choose. Say 1:22 can be chosen like this. So I had made a mistake somewhere here. What was that? Okay, I should not have put it like this. I could have iris. Okay, you can choose from 2:3, something like this, so that you can choose between arbitrary numbers. From 2 or 1 up to 2 and 3. Only 1 is there. You can actually experiment with this. Let's say if you say 4, you will get something like 2 and 3. So this is because of that indexing problem. So 1 minus will be taken from the last value. Okay, now this is sample, and this is so if you want to examine the column headers, you can have the columns value. So how does it look like? What is the size? You can have the iris shape I will give you, and this already we have seen 1:22. And say, and in between value you can choose like 20 from 20 to 22. So that will give you 20 and 21 rows. Maybe you can calculate statistical parameters of various attributes this way. Describe which will compute mean of each column, count total count how much is there, then standard deviation of each column, minimum, maximum, quantile values. So these are the statistical parameters that you can choose. Maybe another thing is information. iris.info will give you various information about your values, how many values are there, what are the parameters, etc. So this is a basic idea about our pandas data structure. So I think I will stop it now.